or greatest common factor of 12, 24, and 32. So some of you are asking, is it 3, is it 6? Every number has to be divided evenly by that number. So 32 can't be divided by 3 or 6. 2 is a good start, but we can divide everything here by a number bigger than 2. So that's where this greatest common factor comes in. So 2 is a factor. It's not necessarily the greatest. Okay, good. I see some. Good. All right, so let's go ahead and get started for today. The greatest common factor is the highest number that divides evenly into every number. Okay, so let me type that out. If you are taking notes, you can write this down. Greatest common factor, the highest number that divides evenly into all numbers. So in this case, all numbers meaning the numbers that you're given. Whoops, why is that not going? There we go. Okay, so the first thing that I recommend doing when you're given 3 numbers is we're going to go ahead and start and say, okay, based on these 3 numbers, are they all odd or all even? Do we have even and odd? So the reason that we do that is if all of your numbers are even, yeah, we can start by saying, okay, so we know if they're even, then they're all divisible by 2. And from there, we can go up into, okay, so 2, that makes sense. So now I can say, okay, so I'm going to start at 2. What about 3? So 12 is divided by 3. That's great. 24 can be divided by 3, but 32 cannot. Okay, so far, the highest number that they all have in common, meaning I can divide them all by 2 and get a whole number, okay? So 3 was a no-go. What about 4? So 12 divided by 4 is 3. 24 divided by 4 is 6. And 32 divided by 4 is 8. So now it's no longer 2. It's now 4. The reason I know to stop at 4 is because the only factors I have of 12 are 1 and 12, 2 and 6, 3 and 4. Okay, so those are the only factors. So we've gone through 2, 3, and 4. We can try 6. Okay, so 12 divided by 6 works. 24 divided by 6 works, but 32 divided by 6 does not work. And then 12, obviously 12 goes into 12 and 24, but not 32. Okay, so the GCF of 12, 24, and 32 would be 4. So what you can do is take either your smallest number or your biggest number, and you can list out the factors. So for 24, I would have had 1 and 24, 2 and 12, 3 and 8, 4 and 6. And you can just start going through each of those. Okay, that 6 is not one because 32 divided by 6 gives us a decimal. Good question. All right, so let's go ahead and today we are starting, this is going to be 0B.01. So we're starting a new unit. Laurel, to answer your question, if you did the 0A review on the weekend, I went through on Friday and if you did all of it, showed all of your work, I wrote on the first slide, like +5, and then I wrote to you what your new grade was. But some of you did the review before the test. So if you didn't take the test when I had gone in to look at the review, I'll go through hopefully today and get those updated. But check your first slide because it will tell you if I updated your test grade and what it is now. All right, so today we are identifying the greatest common factor so that I can factor out the GCF from a polynomial. Factor is the big word here. Okay, this is our new word. I'll know I've got it when I can correctly simplify and write the polynomial as two factors. So we've talked about polynomials in the first unit. Today, unit 0B is going to be all about factoring. So for the next 2 weeks or so, we're going to be talking about factoring every day. So I want to go over what is factoring. So factor the following. Remember how we were just talking about here, factors are two numbers, two terms that you multiply together to get the product. Okay? Well, when we just have numbers such as 12, 2 and 6 are factors. 2 times 6 gives me 12. Now we've got polynomials. Okay, so there are two, we can multiply terms together to get this final answer. So when you're factoring, the first thing you're going to do, step 1, is find the GCF. First, we're just going to find the GCF of our coefficients. So if I look here, remember that coefficients are numbers in front of variables. I'm going to go ahead and highlight my coefficients. So I have 9, 15, and 12. All right, so I know I'm going to start with, I'll just start with 9. So my factors of 9 would be 1 and 9, and then 3 and 3, right? Okay, so obviously 1 is a factor for all of these. That's not our biggest. So let's try 3. So 3 divided by 9, that word, or 9 divided by 3, 15 divided by 3, 12 divided by 3. So far, 3 is our winner. 9 goes into 9, but not 15 or 12. So that means our GCF of the coefficients for this one would be 3. The second step is to find the GCF of your variables. So what I mean by that is we have x to the 4th. So that's x times x times x times x. Then we have x squared, which is x times x, and then just x. So I'm asking myself, what is the greatest number of x's I can pull out from all 3 terms? We cannot take an x from a term that doesn't have an x. This one, we have 9x to the 4th, 15x squared, and 12x. So they all do have that x variable. Basically the smallest x is going to be your GCF. So it's 1. I can't take 2 x's. I can't take an x squared from x. I don't have x squared. So my GCF here would be x. All right. Another way that you can do this, if you want to do it as 3 separate terms, you can take your 9x to the 4th and say, okay, we can write out what's called the prime factorization. So prime numbers means they can only be divided by 1 in itself. So 9 written as a prime number would be 3 times 3, and then x times x times x times x. 15 is 5 times 3, x times x. 12x is 3 times 2 times 2 times x. So what we're looking for here is all of the same. We're finding the biggest number, and then how many x's can we pull out? So when we put them together, our greatest common factor of this entire thing is 3 times x, which is the same thing we found over here. So you can do it coefficients first, then variables, or you can do it all at the same time. Once we've found the coefficient, once we found the greatest common factor of the coefficients and the variables, we now are going to pull that out. When we pull something out of an original polynomial, and now we're writing it as two factors, we're actually dividing. So we're going to take our original polynomial, and this should look familiar from your 0A15 homework. Now we're just going to divide. So I'm going to divide these, I'm going to divide this, and divide this. I'm dividing 3 times. You don't have to write it out as a division problem. Some of you, when you get the hang of it, you might be able to just do it in your head. That's great. But you can write it out as a division problem to keep yourself organized. So what is 9x to the 4th divided by 3x? Here's a helpful hint. When there is no exponent next to a variable, there is a hidden 1. So I would do 9 divided by 3 would be 3. And then I have x to the 4 minus 1. Take your top number, subtract the bottom exponent. So this would be 3x to the 3rd. Okay, here's that written out again. All right, now let's do the second one. Second term, so 15x squared divided by 3x. Again, when there's no exponent next to a variable, there is that hidden 1. So 15 divided by 3 gives me 5. X to the 2 minus 1, so then I'm left with 5x. And then lastly, 12x divided by 3x. 12 divided by 3 is 4. And then I would have x to the 1 minus 1, which is 4x to the 0. And we know that x to the 0 is equal to 1. So it's 4 times 1, which is just 4. Okay, so we've done all of that division, but how do we write it out? The greatest common factor of 9x to the 4th plus 15x squared plus 12x is 3x. So this is our greatest common factor. When we take 9x to the 4th plus 15x squared plus 12x and we divide it by 3x, this is what we're left with. Yeah, Caitlin, let me get through this first one, okay? And then I'll go over questions. And I'll go a little slower on the next one. So, final answer, writing this, we're going to pull out that 3x from our original equation. Okay, so our original equation, again, was 9x to the 4th plus 15x squared plus 12x. So we're pulling that 3x out in front, and everything else gets rewritten in the parentheses. Okay, going back to our exponent rules, if I wanted to go back through and multiply this all out, I should get my original. Okay, so what you are working on today in the course and what we're going to be working on in class is identifying the greatest common factor and pulling it out and then rewriting what's left. So the x squared, Richard, I pulled out a 3x. So 15 divided by 3 gives me that 5. And then x squared divided by x gives me just x to the 1st. Good question. So there was a lot of slides in between where I was showing you exactly like one thing at a time. You don't have to write it all as a division problem. You can do it in your head or step by step if you want. Whatever works best for you. Let's try another one here. So I'm going to give you a hint. So we're going to find the GCF of the coefficients. That's the numbers. Oops. In front of variables, and then GCF of my variables. So I'm going to give you a second. I'm going to highlight the coefficient in green. Good, Eunice. That's a great start. Good job. Perfect. And then our variables here. All right, I'm going to go ahead and open up the chat. Go ahead, only tell me right now, what is the GCF of the coefficients? Laurel, GCF is the greatest common factor. So what you would do is take maybe you can take the biggest or the smallest number. I'm going to take 4. Okay. The only numbers I can multiply to get 4 are 1 times 4 and then 2 times 2. Okay. So what I'm now going to do is take every single one of these numbers. Okay, guys, if you're lost, listen. Okay, I'm explaining it right now. Okay. So if you're lost, stop. Don't worry about the chat. Okay. Just pay attention because I'm explaining this right now, how to find the GCF of numbers. So our coefficients, the only numbers that I can multiply together to get a number 4. Coefficients are numbers in front of variables. So 4, negative 24, and 8. Those are our coefficients for this problem. The only numbers I can multiply to get 4 is 1 times 4 or 2 times 2. So I asked myself, okay, can I divide every single one of these numbers, 4, 24, and 8? Can I divide all of those by 1? Yes, of course. So far, 1 is my GCF. Now, I asked myself about 2. Can 4 be divided by 2? Yes. 24 divided by 2? Yes. 8 divided by 2. All right, so it's no longer 1. Now it's 2. Now I'm going to ask myself about 4. Can 4 be divided by 4? Yes, it gives me 1. 24 divided by 4? Yes. 8 divided by 4? Yes. So we want to choose the greatest. That's the G, greatest common factor. The biggest factor all of these numbers have in common is 4. It's sometimes, in my opinion, easier to start with the smallest numbers and write your factors out because you limit yourself. Like if I started with 24, I would have been doing 1 and 24, 2 and 12, 3 and 8, 4 and 6. But I can't do 24 or 12 because 8 and 4 are not that big. Okay, so start with your smallest number, write out your factors, and then you're just going to go through each of the rest of the coefficients and divide. Ask yourself, can I divide this evenly? Okay, now to find the coefficient or the GCF, well, 8 doesn't work, Erica, because 4 divided by 8 doesn't give me a whole number. That gives me 1/2. So the GCF cannot be bigger than your smallest number. It can be equal to the smallest number, like in this case, but it cannot be bigger than your smallest number. So the variable here, we have x to the 4th, x to the 3rd, and x. Okay, the most amount of, the least amount of x's I have, so the most I can take is 1x from each of these. So my greatest common variable is x. So again, finding the GCF of the coefficients, I'm going to start with my smallest number. Finding the GCF of the variables, I'm using the smallest degree of x. Because this term down here, Caitlin, 8x, there's only 1x that I can take from that. I can't take 2 x's if I only have 1 to give. So that means my GCF of this entire thing is 4x. So Angel, we'll get there, but for right now, you don't need to worry about that. If there was a y in every single one of those terms, then yes, you could pull out a y, but we'll get there. Okay, so now when I rewrite this, I'm going to cover this up. Okay, here's my original polynomial. No, Eunice, the coefficients, the GCF of the coefficients was 4. The GCF of the variables was x. Yeah, then you're right, x. Yep, just one x. No, you're fine. Okay, so my GCF was 4x. So that means I'm going to take 4x and put it outside my parentheses. So now I'm saying, what do I have left? So if I took 4x to the fourth and divided by 4x, 4 divided by 4 would give me 1. If you want to write the 1 there, you can. And then I'm left with x to the third. Okay, negative 24 divided by 4 would give me negative 6. X to the third divided by x, so I'm left with x squared. 8 divided by 4 is 2. X divided by x is 1. So 2 times 1, or just 2. So this is how you factor, and you write it as 2. So remember, factoring means that we're writing it as 2 terms that can be multiplied together to get the original. 4x times x to the third minus 6x squared plus 2 is the same thing as this. Yes. So we take our original, Caitlin, good question. We take our original number, 4x to the fourth, and divide it by the GCF, which is what we pulled outside the parentheses. Yes. Okay, here it is written without that 1. So it's not, wait, why wouldn't it be 8? Well, 8 is not a GCF. So 4 can't be divided by 8 and get a whole number. You get a fraction, 1/2 or 1/2. So you have to be able to divide and get a whole number. Well, it is negative, Brent. There's just this 6 in front. So we had negative 24 divided by 4, which is negative 6. So negative 6x squared. Good questions. Okay, let's try. Yeah, Erica, you can divide 4 by 2, but that's not the greatest common factor. So 2 is a factor, but it's not the greatest. Angel, I don't really understand your question. 2 is not okay, but when you say 2 is the smallest, what do you mean by that? What 2 is the smallest? Yeah, but we're not looking for the smallest common factor. We're looking for the greatest. We want the biggest number, the greatest number. Okay, Caitlin, she divided everything in the parentheses from the number outside. Yeah, but she said 4 divided by 24. I said negative 24. So if I go back to this, negative 24 divided by 4 is negative 6. 24 divided by 4 is 6, not 8. Do you want to get on the mic maybe, Caitlin? Or was that just it? You just thought it was 8. That's okay. Okay, Caitlin, go ahead. You can use the mic to ask your question.
You said that it would be 4 divided by negative 24, which would equal 6. But how did you get 1x to the power 3?
So to do that, I did 4x to the fourth divided by 4x. So 4 divided by 4 is 1. And then when we divide exponents, we subtract them. So x to the 4 minus 1. So that would be 1x to the third. Just how I got that one. Any other questions? We're going to do a couple more. Nope, 1's not the greatest common factor. The greatest common factor is what we pulled out in front. Caitlin, does that make sense?
So you just divided the 4x, 4 divided by 4x, and then you just added the exponents?
I didn't add them. I subtracted 4 minus 1.
Yeah, subtracted, sorry.
Yep. So remember last unit we used we learned all of these exponent rules so that we could do this. So when we're dividing terms, so basically what we're doing, and this might look a little more familiar to you, this is what we're doing, okay? We know that 4x is the GCF. So we're going to go back to, this is our original. We're dividing all of that by our GCF. Guys, if you're confused, quit worrying about the chat. You should only be using the chat to ask questions. Okay? You can read the chat, and if you have a question, that's great. But don't waste your time just replying to other friends, okay? Unless you're asking them a question. So, Angel, it's not the GCF because it's separated. We separated it because it was the GCF. So we identified the GCF by, I'll go back to the first slide where we started this. First, we're going to find the greatest common factor of our coefficients. That's what we did here. Then we're going to find the greatest common factor of the variables, and then we put them together. We're going to do another example, so maybe this one will make things click a little bit. And then you don't forget, after class is over, you still have a video in the course to watch, and it has more vocab and some more problems worked. So let's try this one. All right. Find the greatest common factor of 14x to the third minus 35x squared plus 28. So the first thing we're going to do, yep, Caitlin Sapphire, that's a great start. Good. We are going to find the GCF of just our numbers or the coefficient. Okay, so what is the greatest number that divides 14, 35, and 28 all equally? Remember, my hint was to start with your lowest number. So if I have 14, my factors of 14 are 1 and 14 or 2 times 7. Yes, exactly, Angel. Exactly, Sarah. That's a good point too. So we know it cannot be bigger than 14. So obviously 1 works. Does 2 work? 14 divided by 2, that works. But 35 divided by 2 does not work because that gives me 17.5. So 2 cannot work. What about 7? 14 divided by 7, that's good. 35 divided by 7, that gives me 5. That's good. And then 28 divided by 7 gives me 4. There we go. So 7. Okay, but now let's just check 14 just to be sure. 14 divided by 14, that's good. 35 divided by 14 is not. So our GCF of the numbers is 7. Okay, now the important thing is variables We have x to the third, x squared, and then we have nothing. Okay? So we cannot pull a variable out in front. Our GCF is just 7. That's it. So our GCF is 7. Let's rewrite this. We're going to pull 7 out in front. 14, exactly, Angel. The GCF is only 7 because not all of them have that variable of x. Good, Caitlin. There you go. So 14x to the third divided by 7. 14 divided by 7 is 2. And then x to the third is going to stay the same. I'm not dividing any of my variables. Good. Negative 35. Don't forget about your negative in front. Negative 35 divided by 7 is negative 5. X squared. Nothing changes with our variables because we aren't dividing by any of our variables or exponents. And then lastly, 28 divided by 7 is 4. Okay, questions so far?
One question.
Sure.
On this question you just pulled up, how is 7 the greatest common factor of 2, 5, and 4, which are all less than 7?
7's not the greatest common factor of those. 7 was the greatest common factor of 14x to the third minus 35x squared plus 28. Now, in this final answer, what I'm saying is 7 times 2x to the third minus 5x squared plus 4 will give me that original answer.
Okay.
So 7 was the greatest common factor of the previous, like before I factored it out. Now it's not the greatest common factor of 2, 5, and 4. It's the greatest common factor of 14, negative 35, and 28. Good question though. Erica, what's your question? Okay, Angel, why don't you ask yours after Erica, okay? Erica, are you there? Okay, Angel, go ahead. Correct. So in this case, we aren't using the exponent rule because we aren't dividing any exponents. Good, Maddie. Good question, Angel. Very good question. Okay. Why? Because we aren't dividing exponents. So yeah, we are multiplying here. So this, if we decided to go, so this is our final answer. If we wanted to check our answer, we could easily say, okay, let me multiply this back out. Even when we multiply it back out, we're just multiplying a constant by these. So we're not multiplying exponents and exponents. Before I give you your exit ticket, I had one ask me to do one that's like one on the quiz real quick. So this is, today you're going to take a 0B.01 quiz. This is like number 1. So let's say that you have an expression that looks like 25x minus 10. And you're finding the GCF. So if it says what expression is equivalent, you're going to find the GCF. So what is my GCF of the numbers here? Numbers are 25 and 10. Good, 5, exactly. So I'm going to pull a 5 out in front. what am I left with? Well, 25 divided by 5 gives me 5. So 5x. 10 divided by 5 gives me 2. So minus 2. Yep, exactly. And there's no x because 10 doesn't have an x. Exactly. No, Richard, so the definition of GCF is that it's the greatest factor that evenly divides a number. So it's not a factor if it doesn't divide it and give you a whole number. So no decimals. Good question. Okay, I have one like little exit ticket that we're going to do. So what I want you to do, yeah, you can pull out negatives as long as when you pull out a negative, you switch the sign. Normally, though, I would keep your GCF as a positive number, almost always. All right, so your exit ticket. The first thing you're going to do is you're going to just send me the GCF. Oops, hold on. This is not even supposed to be here. Okay, your GCF is just this top part. And then obviously, some of you probably just saw the greatest common factor, but go ahead and send me your greatest common factor. Okay, and then once you have your greatest common factor, you're going to divide and send me your final answer. So your final answer should look like whatever your GCF is, some number, then parentheses, whatever is left. So send me that in questions and answers, your final answer when you think you've got it. If you've got it correct, I will tell you, like I'll say your name and say you've got it. Go either work on your quiz or go watch the video in 0B.01. Caitlin, how do you want to show that? Sure. You should have camera availability. Okay, let's see. Angel, good job. You're good. Anna, you're good. That's so cute, Caitlin. I love it. So Sarah, just be careful of that first one. You have 7x to the third, but I think you meant 2. Luis, you're good. Skylar, you're good. Mason, you're good. Thank you, Josh. You're good. Anna, you're good. Anya, you're good. Grace, close. So Grace, for some reason, you lowered each of your exponents by 1, but our greatest common factor here is 7. Okay, so 7 should be here on the outside. We're not dividing any of our exponents, so check that. Sapphire, you're good. Adrena, you're good. Garrison, you're good. Jacob, you're good. Wesley, good. Sarah Banks, you're good. Caitlin, you're good. Just make sure that first one is 2x to the third. Brent, you should have 2x to the third and then minus 3x squared plus 4. Check yours again. Garrett, you're good. It's not time, but I want to give you these last 5 minutes to either, if you understand this, to go take your quiz, so that way you don't have homework to do later, or if you don't understand it, watch the video and then take your quiz. Liza, you're good. Grace, you're good. Richard, can you explain to me your question that you asked me? Did you have to say what the GCF is just as is figured it out? Oh, sorry, just as you figured it out. I gotcha. Sorry. Josiah, check your variables and their exponents. So this should still be 2x to the third because we didn't do anything. We didn't pull out any x's. Yes, Jonathan. Stormy, yes, except 2x to the third. Josiah, you're good. The quiz is 0B.01 quiz. Abdullah, you're good. Adelina, you're good. Laurel, you're good. Brent, you still have that minus 5x squared. I don't know where you're getting that 5. It should be 3. But otherwise, you're good. Brianna, you're good. Liv, you're good. Elliot, you're good. Okay, thank you, Josiah. Richard, good. You're good. Sorry, guys. I'm just trying to type it in. I mean, catch up with all of what you typed in. Jonathan, you're good. Eunice, you're good. Yeah, you can go. If I told you that you're good, then you are good to go. Either do your quiz. Raul, you're good. Bye, guys. So for those of you maybe that need a little bit of help, negative 21 divided by 7 would give me minus 3, and then my x squared. 28 divided by 7 is 4. Okay? All right. Yeah, Caitlin?
I have a quick question. Is there any way you can go to questions that are similar to the last two on the quiz?
I could probably write some out. Let me look.
Cute gecko.
Let's see. Okay, so I think it's probably just the bigger numbers that have you a little bit messed up, but let's say we have 400 x to the third minus, let's do 100 x. All right, so what is my GCF of just the numbers? 400 and 100. What do they have in common? Like, what's the biggest I can divide both of them by? Okay, Shania, I'll look into that. Thank you. Caitlin, what do you think?
Can you hear me?
I can now, yeah.
100.
Exactly, good. So we know we're going to pull out a 100. And then take a look at your exponents here. X to the third and x. So I can pull out one of these x's. So 100x is going to come out in front. Now I'm just going to divide. So 400 divided by 100 would be 4. X squared divided by x would, or sorry, x to the third divided by x would be x squared. Then 100 divided by 100 gives me that 1. So we still had our minus sign here. So minus 1. And then x divided by x is 1. Does that kind of make sense? That's kind of like number 4. And then, yeah.
Do we always subtract the exponent?
When you're dividing, yes. One that is like number 5. Let's do negative 49x squared plus 21x. All right, so take a look here at your numbers, 49 and 21. What would be our GCF for the numbers? You can start with your factors of 21. There's only 4. What do you think? What would be our biggest number? Good, Erica. So I'm going to pull out a 7. And then my biggest variable would be x. So if I rewrote this, we would have 7x on the outside. Then I would have negative 7x plus 3. Now, sometimes in multiple choice, it doesn't quite give you that option, right? So I might say, oh, well, I don't see that as an option. So you can take this negative and pull it out with your GCF. So now if my GCF is negative 7x, negative 49 divided by negative 7 gives me a positive 7. And then I would have the minus 3 because negative 7 times negative 3 would give me that plus 1.
Where did you get the, I know how you found the GCF of 7, but why did you put like negative 7x plus 3? Weren't you supposed to put 49 and 21?
No, because when I pull out my GCF here of 7x, I'm dividing. So if I just pulled out the GCF and then rewrote everything here, now that's not the same. So what I'm saying is that this equation...
Divided 21 divided by 7, that gives you 3. And then
21x, yeah, 21 divided by 7 gives you 3. X divided by x gives you 1. So you just have 3.
And then what about the 49? How did you... Wait. Oh, negative 49 divided by 7 is 7.
It's negative 7, yeah. And then when I divide it by a negative 7, now it becomes positive like it is down here. Yep. All right. I'm gonna go ahead and, no, you're fine. That's